All right, for 27, we're given this sort of diagram, and we're told that two samples of water of equal mass are heated to 60 degrees Celsius, which we see here, and then one sample is poured into an insulated container, the other into a non-insulated container. And we see, the labels here with the squares and dots. So the samples are then left for 70 minutes to cool in a room having a temperature of 25 degrees. Okay, so they're in a room temperature 25 degrees. The graph above shows the temperature of each sample at 10-minute intervals. Which of the following statements correctly compares the average rates at which the temperatures of the two samples change? Okay, so again, correctly compares the average rates at which the temperatures change. Let's read the options. So A reads in every 10-minute interval the magnitude of the rate of change of temperature of the insulated sample is greater than that of the non-insulated sample. Is that the case? No. For example, look at this very first 10-minute interval. Here, the magnitude of the change in temperature of the insulated, so from here to here, is less than here to here, right? So the non-insulated changes in temperature more, so the magnitude of the change in temperature is greater for the non-insulated sample. So this is not correct. What about B? In every 10-minute interval, the magnitude of the rate of change of the temperature of the non-insulated is greater than that of the insulated. Is that the case? Well, let's see. Let's actually we can look all the way at the end here. And at the very end, from 60 to 70 minutes, we can see that the non-insulated, right, the non-insulated barely changes. I mean, from here, it looks like it doesn't change at all. While the insulated container is still changing. So from 60 to 70 minutes, the magnitude of the rate of change of the temperature for the non-insulated is less than that of the insulated. So that means that B is also false because this isn't the case at every 10-minute interval. What about C? In the interval from 0 to 10 and from 10 to 20, the rates of change of temperature of the insulated sample are of greater magnitude, whereas in the other minutes, it's greater. Okay, well, let's just at least look at this first part. So basically from 0 to 20 minutes, the rates of change of temperature of the insulated sample are of greater magnitude than the non-insulated. Is that the case? No, because from 0 to 20, we can see that the rate of change, or again, like slope, the magnitude of the slope of the insulated is less than the magnitude of the slope of the non-insulated, because over the same amount of x, over the same change in time, the temperature of the non-insulated drops more. So your change in y over change in x is greater, your magnitude of your slope is greater. So that means that this statement is not correct. So that leaves us with D, but let's make sure that it's correct to know that we didn't miss anything. In the intervals from 0 to, let's just say, 20, the rates of change in the non-insulated sample are of greater magnitude. Okay, that's correct. That's what we just observed. And then it also says that in the intervals from 40 to 50 and 50 to 60, so just 40 to 60, the rates of change of temperature of the insulated sample are of greater magnitude. So from 40 to 60, to 60, so to here. Is that the case? Yeah, it is. We see it, right, that the non-insulated sample is pretty much barely changing in temperature at all here, while the insulated sample is changing in temperature. So again, over the same x, now the insulated sample is changing more in temperature. So the magnitude of the slope, or the magnitude of the rate of change for the non-insulated, is greater than the insulated. So that is, in fact, what we see. So D is our answer, as it's the only one that actually accurately describes the data.